Okay, so I have show you one of the special case under the two power of k factorial designs, and then what is meaning by the sum or square, and then how do you form the contrast from the sign table. Okay, then from the sign table, then we can calculate the sum or square, and then at the same time we can calculate the effect for each of the factors. Okay, so of course the contrast here, they must have a reason why it's here. I show you about the example of the sum or square for A is the formula were given by here, and then from here we do the expansion, then we can see that the formula can simplify to the form of the contrast square divided by 4n. But why is a 4n here? Because here have a divided by 2n, and then after that you have a 4 in 1 is 4n here. Okay, so in general, they always must be the 4n here. You also need to think about it. Okay, for the 2 factor is 4n. If the 3 factor, is it the 6n or the 8n? So all these things we need to care. So here I just give you the special case under the 2 factors. They were given by the contrast square divided by 4n. Okay, for the sum or square. Where else for the effect you have a divided by 2n here. Okay, so later on we can see the general formula. Okay, so I have gone through the example of here. The ANOVA table is similar to the factorial design, except right now you have a 2 levels only. Okay, so this one is a residual plot. I produce it using the Minitab. Okay, of course you can use the R to produce a similar plots here. Okay. Before I go through the general formula, this is a graphical way of the presentation for the 2 power of 3 factorial design. So if we consist of the 3 factorial design, so means that we have a factor A, factor B, and a factor C right now here. Okay, so under the 3 factorial design, we can use the graphical way to show it out, where we list out the box, the square in the 3-dimensional way. Okay, so if we study the factor A and the factor B, the factor A at the high level and at the low level, we want to know the effect of the changes from the low level to high level. Then what we consider is for the factor A, these are the surface under the factor A here. You have another 8 points, another 4 points under the factor A at the high level, 4 points for the factor A at the low level. So you just get the average value of here. You just take the average value of here. You get the difference. Therefore, you will know the effect from the factor A. Similarly, for the factor B also from the low level to the high level. For the factor C, from the low level to the high level. So altogether, there are still is a 4 points. You have a 4 points here. So if you are looking at the iteration effect of the AB, of course, you consider the cross product, the cross of the difference here. If you're looking at the AC, you are looking for the cross here. If you're looking for BC, you're looking for cross here. Okay. Then, of course, when you deal with the ABC, they will look like it's very complicated. This one is the idea of finding the A, B, C, and so on. Okay, the mean effect, the iteration effect, and then the 3-factor iteration effect. So this one is another of the sign table here, but this one is now we are looking at the 3-factor right now. So under the 3-factor, we can observe it. Just now I mentioned to you that you put the plus minus sign here, you need to follow the standard order. Because just now we study only the 2-factor, therefore we have a 1. After that is a A, B, and the AB only. Okay, so here if you have 3 factors, how we want to put in the standard order? We will the standard order will be starting from the 1, and then we list out the A, B. Then after that, we prove the product of the A times B, you get the AB. So after you complete this thing, you have a new factor C. So from the C here, you will have a C times A, AC. you have C times B, you have BC. After that, you have the following one is a C times ABC, you have a ABC. So you need to list down in the following order. So this one is called the standard order you have here. Okay. So again, you want to list down the factor plus minus sign. As I mentioned to you, if you list down the factor A, you can see there is a 1 negative, 1 positive, 1 negative, 1 positive, and so on. If you list down the B, you have a 2 negative, 2 positive, 2 negative, 2 positive. When you go to the factor C, you have a 4 negative, 4 positive. So you can see that if you list down the A, B, C side by side, you have a 1, minus plus minus plus, you have a 2 minus 2 plus, 2 minus 2 plus. If you have C, you have 4 minus 4 plus. So if you list down in the following way, you won't be miss any of the treatment combination, and then as well as your factor A, B, C, and so on. So to get your AB, you just product of these two, you get the plus sign and minus sign. So all these things will be useful contrast for you to calculate the sum of square here. So similarly, you can get the AC is multiplied by the A and the C. If you do not follow the standard order, then you mix it out, then you will face the problem of the list down, some of the them is repeated or some of the observation of the combination is missing. So this one will be the AC, BC, and ABC. You just product of the 3A times B times C. So minus, minus, minus become minus. Okay. So once you get your plus minus sign here, you can get your contrast through the treatment combination here. So the first one, factor A will be minus 1 plus A minus B plus AB and so on. Okay. So you have a plus minus sign here. Okay, so now I show you the general formula for the sum of square. So the general formula for sum of square will be given as the contrast square. The contrast you square it out divided by n times 2 power of k. So just now you have a 4 there is because the 2 power of 2 factor is equal to 4. Okay, where else if you want to know the effect, is a contrast divided by n times 2 power of k minus 1. Okay, so both of them have a common term is called the contrast. So if I given you the effect, you can calculate the contrast, and then from the contrast, you square it out divided by n times 2k, you can find your sum of square. So these two is can link together. So for this one is only for the case of the 2 power of k. Okay, the factorial design of the 2 power of k. So where you can use your contrast. So what is meaning a contrast will given by the plus minus sign here. You have a minus 1 plus A and so on. Okay. So here I have shown it to you the general formula for the contrast given by this thing. Okay. So now we go through the following example where if you want to study only for the 3 factors, with each factor, you consider only 2 levels. Okay, so if we consider, for example, the factor A, we want to use a gaps, our the width of the centimeter, they measure in the centimeter, so they have a 0.8 to 1.2. And then for the B1 is a certain flow, you have a 125 until the 200. So you use the power level is from the 275 to the 325 here. So you using the certain range for the low level and high level. We will expect that if there is no difference in these 2 levels, if there is no difference, so we expect in between there is roughly is no difference. Okay, this one is why we using the 2 power k factor design to try to scream out the factor. Okay, otherwise you need to run many levels. Okay, of course, if using this way may not be accurate, then there is another case is called 3 power of k factorial design. Okay, so you only concentrate on the 2 levels here, then we expect that from these 2 levels, what is the results they have, if there is any significant difference or no significant difference. Okay, so in this result here, we want to study is 3 factors at the same time. Every factors run for the 2 levels, and then each one you repeat for twice. Okay, so once you repeat for twice, here is a result. Here is a data set you have. Okay, so as you can see out, the data, the factor here I use a coded is -1 + 1 and so on. Okay, the 2 negative, 2 positive. This one is a 4 negative, 4 positive. So for each one repeated, then this one, the 1 here is referred as that all at the low level is using the notation 1. For the A at the high level, you use a notation A, and the rest of them will be happy here. Okay, so this one refer to their total. So once you know your total, then of course you can calculate the contrast, and then from the contrast there, you can calculate the sum of square, the sum of square. Okay, so here I show you one of the example. If I going to calculate the effect A, the effect will be the effect of the A will equal to the contrast divided by the n times 2 power of k minus 1. So in this case, your n is equal to 2 power of 3 minus 1. So therefore, you get this one is here. Then of course, here will be the contrast for the factor A. So you just substitute the total for each one. Then you calculate the factor A effect will be -101. Okay, so there is a negative effect. You increase from the low level to the high level, then the effect is negative. Okay, so this one is for the effect of the A. Of course, you can calculate the effect of the B as well, and so on. So I leave it for you to try to calculate it yourself. Okay, you can be calculate the effect of the B, and then of course you can have a AB, AC, BC. Okay, so here I just show you is the effect of the A. You can calculate the effect for the B. You can have a C. You have a AC. You have a AB. Okay, of course you have a AB first, followed by AC. Then you have this one. After that you have VC. Then you have a ABC. You can calculate all these effects here. Okay, so all these effects I will leave it here. I do not want to calculate it here one by one. Okay. Okay. So from the just now I show you the calculation is this one is the effect here. Okay, the effect is -101.625. You also can calculate the effect for the B, C, and the AB, AC, BC, and ABC. So all this is the effect. Some effect is positive, some effect is negative. So this one factor A is an effect is negative. AB and AC and BC will be negative effect. And then for the BC and the ABC, the effect is a positive. Then if you observe that here from the effect itself, you can see that if you relatively C will be the largest effect. The AC will be the negative effect, but is considered as second largest. Okay, whereas the effect of the here ABC, BC is close to the 0. Okay, they are relatively close to 0. Similarly, for the effect B also close to the 0. So from the effect here, if you observe overall effect, we will expect that this one, and this one, if we test the significance of these factors, since that they are not significant enough. Okay, they are not significant. This one is only we observe from their effect. Okay, then after that, from the effect itself, we can get the sum of square. Because once you get your effect here, you can get the sum of square. So the sum of square just now I have mentioned to you, the effect is just okay, the effect is just a contrast n times 2 power k minus 1. So the sum of square here will equal to the contrast square times n times 2 power k. Okay, so you from the effect here, you can convert it to the contrast, and then from contrast, you can calculate the sum of square. Okay, the contrast square divided n times 2 power k, you get your sum of square. So obviously you can observe that all these things is a sum of square for the factor A until the factor ABC. Also, you know that you can be calculate the sum of square for the total. And then you use the sum of square for total minus away all the sum of square, you get your sum of square for the error. So if you observe the sum of square here, also as an effect here, this one is contribute the largest sum of square, followed by the second one is a second sum of square. So if we consider the percentage of contribution of the sum of square, okay, so this one will contribute the largest percentage. Okay, so they concentrate on largest percentage or the effect is quite large. So if the effect is quite large, so you will expect that this factor will be the significant. Okay, where there is a changes in the factor level there. Okay, so in that case, you will think that the sum of square will be quite large, and then the percentage contribution is, we just review for the graphical here, this factor will be quite important here. Okay. So this one is still we not confirm yet, because we still need to perform the analysis of variance table to confirm that whether this factor is a significant different or no significant different. Okay, so we will proceed with the following table here. If we perform the analysis of variance, okay, this analysis of variance, I think I will using the similar way where I just put in the R. Okay, for the 3 factor onward, I will do it in the R. Okay, for the 2 factors one, we can do it manually calculation. Okay, so obviously you can check the F value is from the F value here is of course the mean square divided by the mean square for the error. You get your F value, and then in this table I also show you the P value. So clearly if we set here the P value here is a very small. This one also very small. This one is also very small. So look like we only have only these 3 factors will be important factors here, where the factors is a factor A will be the important, and then the factor C will be important, and then after that we have a factor AC. Okay, so means that the A and the C will be iteration of here also important. So from the 2 power k factorial design, we can identify that which factor they are important. So from here, the factor A is a since that is very important. Then if we want to study for the different levels of the factor A, then we will put more levels instead of only 2 levels. Then we can identify which level have given you the largest yield, or which level will give you the lowest yield. Then we can be studied in detail. Okay, so for the 2 power k here, we can identify this 3 is here. Of course, these 3, the rest of them is the p value is very high, so it's not the important factors here. Okay, so the cash flow, the gas flow and the iteration of the AB and so on is not really significant. Okay, so these are the 3 factors is important. Because after we identify the important factors, we can go to the regression analysis to form the model. Okay, to form our regression model. That one is later on after this chapter, I will go through the response surface methodology. Then we will make use of this information to form the regression model. It's very simple regression model. Then from the model itself, we can do the prediction. Okay. So the calculation of the sum of square, I no need to repeat it. I believe that all of them is repeated. So the degree of freedom, all of them is become 1, because as you know that the degree of freedom for factor A is equal to A minus 1. For the factor BC also the same. For the AB will equal to A minus 1, B minus 1. Okay, because all of them is 2 levels, so therefore you get the answer 1. For the factor ABC, you get the A minus 1, B minus 1, C minus 1. So the degree of freedom is still 1. Total degree of freedom is 15, minus away the rest, you get the degree of freedom 8. Okay, so this one is how you want to identify the important factor from the ANOVA table here. and then at the same time, your number of replicate is more than 1. Your number of replicate is more than 1. Okay, so the similar thing over here, if your n is equal to 1, the error sum of square, you are unable to calculate it as well. Okay, because this one is one special case of the factorial design. So this one is a mini type results. I just show the summary to make sure that I have what the summary I have. And then this one is the ANOVA table I have. Okay, I using the same form function is a AOV. So the ANOVA table will show me this is a result. So this result will consistent with the result above. Okay, it's consistent with all these result above here. Okay, so the p-value, they also put the star here to show you that they are significant different at which percentage level. Okay, at the 0 here or the 0.001, 0.01 or 0.05. Okay, so here is you can review it out where this p-value is very large, the flow is not significant. Similarly, for the iteration effect of here is not significant. Okay. So this one will be this part. Okay. Then after that, after this page, I will show you is about this thing. Okay, for the mini tab results as well. Okay, so for the mini tab results, the important thing is only at the bottom first, at this part. The important thing is only at here. Okay, because here is just show you the regression model. This regression model, I will repeat it in the as I mentioned to you, is a response surface methodology. Okay, the effect, of course, you know the effect itself is a no. You know the effect, you have studied the effect. But beside the effect, all these things, I believe that you are never seen before. Okay, because this one is about the model part. So because when you run the result, they will come out all together. So now, for the time being, we only know about the effect. The important thing is just the effect itself. Okay. Okay. So this plot, I will explain it later. Okay. Then this one is a residual plot for the just now the diagram here. I mean the previous result. It look like your variance is not constant. You can see that the fitted here, the residual versus the variance is large, and then they're small. They have a large, then they're small. Okay, so look like the variance is not the consistent. So in that case, suppose the result there, you need to do the transformation. You need to transform the data, then reanalyze again. But even though the graphical here show that there is a variance not constant, okay, but you still can be performed using the certain statistical test. As I mentioned to you, is a Butler test to test for the variance is the variance is constant or not constant. Sometimes you graphically, you can see that it's very huge. There is a pattern. But when you test it, they show that not significant. So it's no different. Because this thing is just a graphical way. Similar to this plot, we say that the pattern is normal or not normal. Because if you refer to the histogram, it looks like it's quite symmetrical. But the normal probability plot also show you that they are quite close to the line, but there is a pattern here. Okay, so of course, based on the graphical one, sometimes we cannot be sure that what is the result, whether it's normal or not normal. From here, it looks like they are symmetrical, but it's not really the normal. So what we can do is we can use the goodness of fit test to test whether this pattern is really the normal shape or not. Okay, of course, like this one is a symmetrical only. Okay. Okay, so for the previous plot one, I will go through with you in the next section. Okay, so I think I will stop our lecture class until now, until here. Okay, until this page is actually I will switch this page to another page because this one is okay. This page is should be the same example, but because I still not discuss about this thing yet, because this one will deal with some mathematical formula where it's show you in the following one. I need to discuss. Okay, so I will discuss with you all in the next week. Okay, so for your information, Next week we have a tutorial. So our lecture will be the same time is from the 6 until the 8:30. After that, we have a 8:30 until 9:30 is our tutorial time. Okay, so I will include the tutorial. The tutorial question will be cover the previous one, the factorial analysis.